You know how sometimes a seemingly small injury just sticks around and it turns into this chronic, nagging pain that's way bigger than the original problem? Well, have you ever wondered why that happens? Today, we're going to dive into the incredible science that completely flipped our understanding of pain on its head. We're looking at the work of pioneers like Lorne Mendel, who helped discover something wild. Our nervous system can actually learn to turn up the volume on pain.
Okay, so let's start with a basic question. What is pain, really? Most of us, we think of it as a pretty simple on-off switch, right? You touch a hot stove, a signal goes zop straight to your brain, and you yell, ouch. Simple, cause and effect. But what if I told you it's not that simple? Not even close.
For the longest time, the scientific view wasn't too far off from that simple switch idea. But then, a series of discoveries revealed something way more complicated and, honestly, way more interesting. It turns out our pain pathways aren't just fixed wiring. They can learn, they can adapt, and crucially, they can learn to make pain signals much, much louder over time.
So here's how we're going to unpack all of this. First, we'll talk about why pain isn't just a switch. Then we'll jump back to the 1960s to look at a huge discovery called Windup. After that, we'll see how things got even more intense with the discovery of the hypersensitive shift. And finally, we'll pull it all together and see how these two big ideas tell one single story about pain.
All right, let's kick things off with part one. Pain isn't a switch. And to really get this, we need to introduce the two main characters carrying signals around our body. So our nervous system has these two main types of nerve fibers. On one hand, you've got the big A fibers. Think of them like high-speed, insulated internet cables. They shoot signals about touch and pressure to your brain super fast. But then you have the small C fibers. These are more like old-school, uninsulated telephone wires. They're slower, and they carry the signals for that dull, burning, intense kind of pain. And these C fibers, they're the real key to our story. And that brings us right to our second part, and the first whoa moment in our story. This all went down in the 1960s with the discovery of a really weird effect that scientists eventually named Windup. Now, this didn't just come out of nowhere. It stood on the shoulders of earlier work. Scientists knew about the different fiber sizes way back in the early 1900s. And by 1960, they'd confirmed that to get a real pain sensation, you had to fire up those little C fibers. But then, in 1965, two researchers, Lorne Mendel and Patrick Wall, were doing an experiment, and they saw something no one had ever seen before.
They discovered what we now call wind-up. So what is it exactly? Well, it's what happens when you repeatedly zap those C fibers. You'd expect the same zap in to give you the same response out, right? But that's not what happened. Instead, the neurons in the spinal cord that were receiving the signal started freaking out, firing back with longer and more intense bursts each time. The system was, quite literally, winding itself up.
And this right here, this is a picture of that exact moment of discovery. It's a dot raster plot from their original 1965 paper. I know it looks a little abstract, but it's basically a live recording of a nerve cell firing. Every single one of those little dots is the cell yelling, "I'm firing." This is the very first time anyone in the world had actually seen the wind-up phenomenon.
Now, to really appreciate this, you have to see the comparison. Let's look at the right side of the plot first. This is the baseline, the control. They're only stimulating the fast A fibers here. See how each little shock at the bottom gives you a nice, neat, predictable little burst of dots up top? It's stable. One signal in, one consistent signal out. Totally normal. Okay, but now look over to the left. This is the game changer. Here, they added the slow C fibers into the mix. And you can see it plain as day with every single pulse. That column of dots, the neuron's response, it just gets longer and longer and even longer. It's incredible. The system isn't just passing along a message anymore. It's screaming it. It's actively cranking up the volume. That is wind-up. The easiest way to think about this is with an analogy. Let's call it the pain volume knob. Wind-up is kind of like hitting a button over and over, and with each press, the volume on an amplifier turns itself up for a few seconds, getting louder and louder before it eventually calms back down. It's a temporary boost, totally dependent on that repeated input. I mean, this was a massive deal. It proved the nervous system's response wasn't set in stone. But, wind-up was still a pretty short-term thing, triggered by artificial electricity in a lab. So the next logical question was, okay, what happens with a real injury that lasts for a while? That next piece of the puzzle came about 15 years later. So in 1983, a scientist named C.J. Wolf tried something a little more true to life.
Instead of just zapping a nerve, he applied a mild burn to the skin and then watched what the nervous system did. And what he found was something much bigger than Windup. It was a form of hypersensitivity that lasted way longer and spread out much further.
And his conclusion, right here, was absolutely revolutionary. He basically said that when you get hurt, the extra pain you feel isn't just coming from the damaged skin. No, it's also because of changes happening inside the central nervous system itself, in the spinal cord and the brain. The system wasn't just a messenger anymore, it was actively changing its own programming.
And this gave birth to the whole concept of central sensitization. So what is it? It's basically a state of high alert or hyperexcitability in your central nervous system. The scary part is that this state can last long after your original injury is healed. And even weirder, that feeling of sensitivity can actually spread to parts of your body that weren't even hurt in the first place. So we've got Windup from 65 and central sensitization from 83. They sound kind of similar, but they're not the same. So for our final section, let's put them side by side and see how these two puzzle pieces fit together to tell a bigger story.
On a biological level, they definitely have some things in common. They both get started because of those small C fibers we talked about. They both rely on the same little chemical doorways or receptors in the spinal cord to work their magic. And at the end of the day, they both do the same basic job. They make the neurons in your spinal cord shout louder. But they are definitely not the same thing, and this chart breaks down the differences perfectly. So the trigger for Windup, it's these very precise artificial electrical pulses in a lab. But for central sensitization, it's a real-deal tissue injury, something like a burn or inflammation. And look at the duration. This is huge. Windup is super fast. It's there and gone in less than a minute. Central sensitization, though, it builds up over hours and can stick around for a long time. And maybe the biggest difference is the effect. Windup just makes the same input feel stronger. Central sensitization makes the whole system go haywire, making it hypersensitive to literally everything, even a light touch. Let's go back to our pain volume knob one last time. If Windup was the volume knob turning itself up for a few seconds, central sensitization is like the entire amplifier has gone bad. It's now blasting painful static even when the input is tiny, and that volume knob is basically stuck on max for hours, or days, or even longer.
And look, this isn't just some weird science experiment. As Lauren Mendel, one of the original discoverers, wrote recently, these two things, Windup and central sensitization, are basically our best models for understanding real human pain. They are the key to unlocking the mysteries of many chronic pain conditions.
And that's the whole point. This science directly explains real conditions that millions of people live with every day. Ever heard of hyperalgesia? That's when a paper cut feels like a serious wound. Or allodynia? That's when something that shouldn't hurt at all, like your clothes brushing against your skin, causes agony. These aren't in someone's head. They are the direct result of a centrally sensitized nervous system.
So we've gone on quite a journey, right? From seeing pain as a simple switch to understanding it's this incredibly dynamic system that can actually learn. We've met Windup, the short-term volume boost, and central sensitization, the long-term, system-wide state of high alert. These discoveries were everything for understanding chronic pain, and they leave us with one massive and actually pretty hopeful question. If our nervous system can learn to amplify pain, how can we teach it to unlearn it?